Today we are working on factoring again, but this time you actually have not the factoring with the X puzzle. We actually have an easier one. It's called factoring difference of two squares. And where do you apply this? When you actually have a binomial. Binomial means two terms only. If you remember, you did trinomial factoring before, which was ax squared plus bx plus c. So this one is trinomial. And then you actually use the X puzzle to factor it, where you have the answer as two set of parentheses. Today you're working on the binomials, which is just two terms, and actually factoring is very easy. The method that we call to do the factors of binomial is called difference of two squares. Also in short form, it could be called DOTS. D.O.T.S. So difference, D stands for difference of two squares. What is difference in math? It's a subtraction. So your equation, number one, should only be binomial. So this doesn't work if it's a trinomial. This only works if it's a binomial, and it's a very specific binomial. It's not a usual, so you have to pay attention. First, it only works with binomial. And difference means it should have a minus sign between, or those two terms should have a minus sign between of the two. So that's your clue. Two means only two terms, binomial. And squares, are those two terms perfect squares? So this is the method that you use only if you actually satisfy all these two things. It should be a subtraction, it should be a two term only, and the both terms should be perfect squares. Both terms should be perfect squares, not just one, both of them. I'll explain you in a second what are perfect squares. So let's just first fill in the blank. The blank is a factoring pattern of the form a squared minus b squared equals to this. Difference of square. One good thing is you do not actually have to remember or memorize this, because in your reference chart, you actually have difference of square given over here. And all I have to do is I'm just going to write dots. So this way I will remember it's difference of two squares, two perfect squares, difference of two perfect squares. And once you have difference of two perfect square, which is a square minus b square, all you have to do is write both of them as a minus b, a plus b. So one time with the minus, one time with the plus sign. That's all. So your goal is to identify whether you have a binomial and whether can you do the dots method over there. Let's talk about perfect square for a minute. Perfect squares are, well, square is a 2D shape where your length and width, or length or height, both are equal. And two perfect squares are the ones where actually two of those lengths are again perfectly same or equal. So I have an example. This side is 4, this side is also 4. So 16. Perfect squares are, 16 is a perfect square because it's a product of 4 times 4, two numbers that are same and perfect. So I'm just gonna list out some perfect squares, because remembering or memorizing first 12 or 20 perfect square makes your math easier. 1 times 1, kids usually forget this one. 1 times 1 is 1. 2 times 2 is 4. 3 times 3 is 9. Then 16. Then 25. Then 36. Then 49. Then 64. 8 times 8 is 64. 9 times 9 is 81. 10 times 10 is 100. 11 times 11 is 121. And 12 times 12 is 144. I'm just going to stop here. So yes, in memorizing these actually will make your math easier. X squared minus 49. Is it a binomial? Or can I apply the difference of, is it a difference of two squares? Let's do that. First of all, is it two terms? Yes. Okay, there's a difference? I'm just gonna apply it like that. Is it a difference? Yes. Is it only two terms? Yes. Are both terms perfect square? Let me check. X squared is a perfect square. 49 is a perfect square because remember it is 7 square. So it's a perfect square. This is a perfect square. So yes, it's a difference of two perfect squares. This is a binomial. I can factor it. Let's try the other one. I'm just gonna write dots so I can check. Is it a difference? No. No, it's not gonna work here. It failed. Let's try on this one. Difference? Yes. Of two numbers? Yes. Are these two perfect squares? Let's check. 49, 7 times 7 is a 49, and this is 7 square. You see that? 7 square minus, is 9 a perfect square? Yeah, 3 times 3 is a 9. So yes, it's a perfect square. So that method will work here. 16. Well, okay, let's start like this. First, is it a difference? Yes. Is it of two terms only? Yeah. Are these two terms both perfect square? Let's check. For 16, 16 is 4 times 4, 16. So it is 4x whole square. It works. And minus 10. 10 actually is 2 times 5 is 10. So no, it's not the perfect square of two numbers. So no, this one is not going to be that form. I can't apply a difference of two squares here. Let's try this one. Is it a difference? Yes. Two terms, sorry, difference, yes. Two terms, yes. Are those two terms perfect squares? Let's check. 36. 6 times 6 is 36, yes, and 3 times 3 is 9. So yes, this is, oh, actually no, this is not. Look at that. 9 has an x with it. So it should have been x 9 square, but it's not. So no, I cannot apply this. No. They're not perfect square. 9 was, but it has an extra x. This one is not a perfect square. It's just a single x. So no, it didn't work. So solving and identifying and solving is actually pretty much simple. Rewrite each expression to find its factor if possible. Okay, so by looking at it, I can see there are two terms. So let me check. Is it a difference? Yes. Is it a difference of two squares? Two terms, yes. Two squares, let me check. X squared, yeah, first one works. 25. 5 times 5 is 25. So yes, both of them actually are square. So this method will apply. So first thing you do is you actually break it down and write as perfect square. So this should be x squared. You may write parentheses like this around. Minus 5 squared. So first thing you do is you rewrite. So first thing you rewrite. Next step is I am going to write it as two set of parentheses. One time with the minus, one time with the plus. Does not matter which one goes first, but it's gonna go in. I usually put minus first because it's a minus. So how do you write it? You put those two terms first with a minus sign, so x minus 5. And then second time you write it with the plus sign. So one time with the positive, one time with the negative. Because your formula said 5 first term square, so a square minus b square. One time you write first term plus second term, and then you write first term minus second term. Those terms could be anything. So that's exactly it was. This was a squared minus b squared. And then I wrote it as a minus b and a plus b. That's all. These two are easy, so I'm just gonna do, well, all of them are easy. But I'm gonna do the next one at the bottom, and then I'm gonna let you do the other two. First, let's write, can I apply Dot's method? Is it a difference? Yes. Is it a difference of two squares or two terms? Yes, but are these both squares? Let's try that. 3 times 3 is 9, and that is n times n is n squared. So it works. So first term is, let's check second term, 121. How did I get 121? 11 times 11. So yes, both of them are, it will work. The method will work. It's 3n whole square like that, minus, you first rewrite it, 11 whole square. So I rewrote it. This is a squared minus this is b squared. Now write it as factor form, one time with the minus, one time with the plus. So it should be 3n minus 11, and the second time it should be 3n plus 11. This is a minus b, and this is a plus b. You should be able to do these two examples on your own, so pause the video over here and do these so I can check them. Okay, so far we are done with all the factoring methods that you need to know for this school year. And right now, I'm gonna show you some techniques that you can actually apply for the factoring, and that should help you. So sometimes you actually have greatest common factors that you have to take before you actually do the factoring. That just gives you good and smaller numbers on the X puzzle, and you should be able to do it easily. So you do not have extremely huge numbers because you're already taking greatest common factor out. So here are some steps that you need to think through. First of all, do I have a greatest common factor? If you have a greatest common factor, you actually take out the greatest common factor, and then you deal with the leftover terms and then do the X puzzle with that. So divide each term with the greatest common factor. So if you have the greatest common factor and you are left with 3 terms, then you solve the X puzzle by the methods that you know. Okay? And if you take out the greatest common factor and now you actually have 2 terms left only, then you actually do the difference of 2 squares, the dots methods. So first you sometimes you have to check, do I have the greatest common factor or not? If you do not have a greatest common factor, then you basically start here. You have 3 terms, you do the X puzzle. You have 2 terms, you check for the dots method, and then you can see if you're able to factor or not. So let's just look into that. I have negative 28x squared plus 49x, and I am going to actually check which method can I apply. So first of all, do I have a greatest common factor over there? And the answer would be yes, I actually have greatest common factor. I'm going to use my spaces on the side. $49 is 7 times 7. And 28 is 4 times 7. So your greatest common factor is 7. Then I am actually looking at whether they have something else common, which is the variable. So this one has x squared and this one has x. So yes, I have x common as well. So my greatest common factor is basically 7x. So GCF is 7x. So I take 7x out, and all I have to do is divide both of these terms by 7x and write the remainders inside, the leftover terms. So negative 28x squared divided by 7x is negative, oh, it's a minus, so I have to take the minus out. How did I miss that part? I have to take the minus out. So it is left, I'm left with positive 4, and x squared cancels x, so I'm left with 4x. Then I have 49x to divide by negative 7x. It's a positive here. So plus divided by minus is a minus. 49 divided by 7 is a 7. X cancels x, so that's it. I'm done. So this is the factor form. So negative 7x, 4x minus 7. This is my answer. Let's look at this one. Does it have any greatest common factor? Doesn't look like. 9 is 3 times 3, and 64 is 8 times 8. Oh, actually they are perfect squares. So let's see if I can do the dots methods. Is there a difference? Yes. 2 terms? Yes. Are those 2 terms perfect square? Let's check. So 9 is 3 times 3. M squared is m times m. And 64 was 8 times 8. So yes, they are perfect squares. If they're perfect square, I'm just gonna first rewrite them and then write them as 2 set of parentheses. So 9m squared is 3m whole square minus 64 is 8 squared. So I rewrote it. Now I'm just gonna write it as 2 set of parentheses, 1 time with the minus, 1 time with the plus. So 3m minus 8, 3m plus 8. So you always actually have to think before you jump into factoring them. They could be simpler than you actually are thinking. So this is my answer, and I'm done. It's a trinomial. So I have to go with the X puzzle. So let's do that. A is 12, B is 1, and C is negative 6. And for my X puzzle, I have 12 times 6 is negative 72, and then 1. Now I need factors for 72. One times 72, 2 times 36, 3 times 24. It doesn't go on, does it go on 4? 72 divided by 4. Yes, it does. 1 and 8. 5, it does not go on 5. Does it go on 6? Yes, 6 and 12. 7. No, but it goes on 8. 8 times 9. This looks like my pair because difference should be 1. I have it. And minus, I need negative 1 multiplied and positive 1 when added. It should be like that. Minus would go with the 8. So I have my X puzzle. Now I'm gonna use the swing and divide method. So A value is 12. I'm gonna divide this by 12 on both sides. And my lowest fraction or simplified fraction would be negative 4 over, sorry, I should be dividing it by 4. 2 over 3, negative 2/3 here. and 3 over 4 here. So these are my two final numbers that I need. You take those two final numbers and you put them as pairs. It should be x minus 2/3 and then x plus 3/4. In factorization, you never have fractions, you just have to swing it. So I'm just gonna take it over here, multiplied, so it's 3x minus 2, and this should give me 4x plus 3, and this is my answer. So this is swing and divide method, the one on the A. I'm not using the B. So if you're one of those who are using the B method, you actually can just use the B method and you should have the same answer. Next example over here is 2x squared minus 50. I can see that this is definitely, I have a greatest common factor, which is 2. So I have to take out 2. And then I'm left with x squared minus 25. Because 2 divided by 2 is 1. And 50 divided by 2 is 25, which I wrote here. After looking at this, I can see it's a binomial. It's not a trinomial. So I have to check whether I can apply D.O.T.S method or not. So let's see. Does it have a difference? Yes. Of 2 terms? Yes, you have 2 terms. Are those 2 terms perfect square? Let's check. Ignore that 2. This 2 is going to remain on the side forever because that's a greatest common factor, so you don't see that. 1. Is 1 a perfect square? Why not? 1 times 1 is 1, so yes. And then x squared, x times x is x squared, so both of them work. So this one is a perfect square. This one is. Let's check with 25. How did I get 25? 5 times 5 is 25, so this is also a perfect square. 2 stays forever out. I'm gonna actually make square brackets here. And this is a square. Okay, let's first write like this. This is x squared minus 5 squared. So I rewrote it. Now I'm gonna write them as 2 set of parentheses, with 1 time with the minus, 1 time with the plus. And that 2 stays outside forever. X minus 5 and x plus 5. This is my answer. So you actually had 2 as a greatest common factor that you take out, and then you can see that actually you had a perfect square. Next example is a trinomial, so I have to check whether I can do the x puzzle or not. But let's see if I have something common, because I can see all of these numbers are even numbers. So do I have a greatest common factor over there? Yes, 2, 2, and 2. 2 is a greatest common factor. So I take out 2. And I'm going to rewrite this thing with square brackets. So 2 divided by 2, I'm left with x squared. Minus 12 divided by 2 is a 6x. And then 16 divided by 2 is a positive 8. So this is what I have. Now again, forget this 2. It's on the side because it's a greatest common factor. Now we have this thing, a trinomial inside. So I have to check whether I can get the x puzzle or not. So a value is basically 1. You're checking the second. We are working with this now. B is -6 and C is 8. Let's see if we have the x puzzle. AC is 8 and B is -6. Let's check for factors. I need 8, 1 times 8, 2 times 4. And looks like I have the pair. It should be 2 times 4, and it should be both negative. Minus 2 multiplied by minus 4 is a positive 8. Minus 2 minus 4 is a minus 6. So yes, these are my two factors. Now I'm going to use swing and divide method. So I divide by 1. And the number stays same. So all you have to do is you write x minus 2. And then in the second pair, you write x minus 4. And just that outside bracket and 2 just stays there. And this would be your answer. So taking greatest common factor actually made it easier. And it all stays like that forever. And I use these square brackets. It just helps you with looking that that was totally outside thing and you don't involve it. Next example is similar, so you actually can pause and work on your own, but you can continue because I'm gonna solve it. Do I have a greatest common factor? Yes, I have a GCF, which is 5. I'm left with 3x squared minus 20 divided by 5 is a 4x. 20 divided by 5 is a 4. This is what I have for the X puzzle. A is 3, B is -4, and C is also -4. For my X puzzle, AC is -12 and B is -4. And let's find the factors. 1 times 12, 2 times 6, 3 times 4. Looks like 2 and 6 will work or should work. I need minus on the top and minus on the bottom, so bigger number should be minus, because 2 times -6 is -12 and 2 minus 6 is -4, so bigger number should be minus. So this is my pair. I'm using swing and divide method. So I would have to divide this by a value, which is 3. 2/3 is the simplest form, so I'm going to take this as I have, and this one would be -1. No, sorry, that's -2. -6 or +3 is -2, so I got it. I'm going to take that number. So copy the outside like this, and then let's write the fraction. It should be x plus 2/3, and then x minus 2. I just have to fix this fraction. It needs to be swing here. So it should be 2x plus 2 and x minus 2. And this would be my answer. I would recommend to practice the same questions and copy the same steps by yourself so you see if you understand or not.